I suppose I have two presentations today. So though others are not here, I want us to start with the recap so that when they eventually join, then we can just continue. So that's why I also started the recording early. So if anybody missed the beginning parts, they can just go back and watch just that part. So please, who can tell us what they remember from this morning session, other than people in group 3? Jessie, Yakubu. Okay, Ruben.
Okay, sir. Yeah.
Good afternoon to you all.
Good afternoon.
Good
Yeah,
afternoon.
in the morning we just learned from our colleagues' presentation on topic models, so pattern models, and there we learned about how models are built, so to libraries, so from the function to models and to finally library. So that means code are being scripted into functions. And so from functions, that is where a block of code are being built. And with that step, it moves to models. And the models are also individual functions that is come together to form a model. Then from model, then it compiled to form a library. So from library there, when you are trying to code, then you can import a model. That means from library, that is where the models are there. So when you are coding, you can import something from, and that is been, or something that is been put in library as something that is built in. So when we talk of the pattern has an inbuilt models that you can import to work on. So that is a little I can also say. I leave it to the rest. Thank you.
Thank you, Ruben. So this morning, yes, we looked at modules and libraries. We mentioned that, so we know how to make functions, right? So we use the def command and then we write some function. We give a function name and then we mention or we say whatever instruction that we want indented under that function. Now, the way we are able to develop functions, we can have functions inside of a .py file, and then that would be our module. So a group of functions is a module. And we also mentioned that modules make up libraries. So you are able to create your own module, but thankfully, a lot of the time, the problems that we are trying to solve have already been solved previously. So we are able to make use of other people's modules. That is, we import their module file, and that's where we are able to utilize whatever functions are inside of their module. And we also said that modules make up libraries, and Python has a standard library where we can go to import, or where we can import modules from. The standard library comes with Python. So it has some modules like the OS module, math module, statistics, random, etc. So for you to be able to use functions from that module, you need to import them from the standard library. And we can do this by using the import keyword or the import command. And we also mentioned that if some packages might not be inside the standard library, but if we want to be able to use functionalities from those packages, there is a package manager for Python called pip, which we can go to, or which we can use to import certain modules that might not be inside of the Python's standard library. And as cloud people or as developers, some modules that we would want to, or some functionalities that we want to import from pip or want to install from pip, the AWS SDK, the requests. We would also want to install Azure, Docker. So those are some packages that we can install from pip because we might not find them inside of the standard library of Python. Okay, who else? So we can create modules, or we can get them from external sources, or we can just get them from the standard library. Who remembers anything else that we covered this morning? William.
Hello.
Hi.
Sorry, I heard you mention my name.
Yeah, what you remember from this morning session?
Oh. Can we go to the next person while I collect my... Thank you.
Okay. We also looked at the JSON module. We mentioned that when we import the JSON module, it will be able to help us use JSON, which is the JavaScript object notation. Would be able to use that to transform our data set into a string. And we saw that it makes it easier when transmitting the data. So what it does is it transforms, no matter the data type you have, it transforms it into a single string. And then after you send it over, it converts back into the, okay, Jennifer. And it converts back into the data type that you initially wanted to transmit, converts back to that. And we also looked at the OS module, which we said helps us run some offers us some operating system functionality, like the environment variable, some functions that we know already, like chmod, chown, mkdir, etc. William.
Yeah, sorry, I remember. We talked about modules.
Okay.
Yes. We did say that modules help oh, what was it again? Yes, they help in simplifying management of cloud resources.
Okay, thank you, William.
You're welcome.
So a module that you might want to use or want to import when it comes to the management of our cloud resources, probably Azure or Boto3, which is AWS SDK for Python, Docker, Terraform. We could get those packages from pip so that we can be able to extend the functionality of our Python code. Emmanuel Odum.
Yeah, Kusha, good afternoon.
Good afternoon.
But unfortunately, I've said what I was coming to say, which is the Python installation package, which is pip, which is used to install, download and install third-party modules. That's what I remember. I also remember file handlers, where we use open read writes to access the content of a file, as Dennis and Co demonstrated. Thank you.
All right, thank you, Emma. So we mentioned that we can use file handlers to, we looked at the open function when it comes to file handlers, and then we had a demonstration from Asari where we used the open function, and then the parameters that we gave it was the file that we want to open and what we want to do with that file. Is it read? Is it write? we had to specify that. So we demonstrated that, and then we're able to print whatever content was inside that file with the example that we did. And we also mentioned that when you import a module, the functionalities of the second imported module always overrides a previously imported module. Joshua.
Yeah, because yeah,
Hi, Joshua.
not to actually drag the class back, but I was working on my labs for networking, and I just want to ask this. On some project I was working on, I used to deploy a OpenVPN, right, for a particular project, and I want to find out if at the side of AWS is possible. So in this case, I was using Yandex Cloud to deploy that solution, which is being managed by the company, right? So in the case of AWS, I just want to know if it is possible.
You want to know if you can use OpenVPN with AWS?
AWS, yes, to deploy that solution.
Yes, it's possible.
It's possible. Okay, thank you.
You're welcome. Okay, so I believe we've covered okay, we also looked at exception handling. Hassanatu made us aware of the wonders that users can do. So you should be able to expect whatever response, so a different variety of responses, and you should always make provision for that inside of your code. So she gave us a typical example of when you would need exception handling, when you have to make some provision in your code so that if the user should enter something that they're not supposed to enter, it will know how to handle it. We also looked at how when we ourselves are running some code, we might come across some errors, some exceptions, and she mentioned that we can make provision in our code so that when those unexpected errors happen, we would be notified the right way and we would know whatever that is going on inside of our code, our code's execution. So we will take the next presentation if there are no questions about modules and libraries. Okay, debugging and testing. Ruben.
Yes, madam. What is the difference between algorithm and model? The difference?
Okay.
Thank you.
You're welcome. Dennis, you want to help us?
Yes, please.
Okay.
Yeah, so Ruben, an algorithm is like a step-by-step process or the logic of a computational program. So let's say the example we develop to read the content of a file, we can write an algorithm which is given that step-by-step process we went through to achieve the final program. So maybe we can say the first step is to declare a variable f1 and then assign f1 to the function open. So that kind of step-by-step process is what we can term as an algorithm. So the logic behind the code. Okay, but then the module, as we said, are pre-built codes. Like people have developed codes for some functions that you may need as a developer within your Python environment. So we looked at the math module in one of the examples where in a demo, you were importing from the math module, and in the math module, you were using the exponential function. So inside the module, there are some functions. If you don't use those modules, you'll not be able to use those functions. The other way around is that it means you have to write your own code to perform those functions, before you can use it within your program. But because you want to avoid that long process and time wasting, people have written those functions down already and bundled them into a module. So you can just import from that module and use it within your code. So I don't know if it's clear.
Oh yeah, that means the model is already packaged and stored somewhere. When you
Yes.
need it, you just import it.
Exactly.
But algorithm is however the process, the step-by-step process that you
Exactly.
have to follow in order to achieve your objective.
Objective, yes. Yes.
Thank you very much.
You're welcome.
All right, thank you, Dennis. Terry.
I've not raised my hand.
It's your group's turn to present.
Oh, okay. Calvin, please. Tell your screen.
Okay.
They go play that right now. Please
So
present the screen for us.
okay.
My friend, I'm no deal.
Kofi.
Who is presenting the screen? Kofi or who? All right.
It is so.
Hey, you guys dislike.
We're not joking as you are.
Hey.
All right, so can you see my screen?
Yes.
Boss,
Please, we can
of
see.
course.
Yeah,
We
right,
can.
sure. Okay.
Very clear, boss.
All right, so who is taking the introduction?
I'll
the
start, but
debug?
I can see this black thing. I don't know if it's on me.
Black, where?
On your far right.
The right side. Yeah.
Oh, okay. Sorry. Yeah. Oh no.
Now we are seeing all black, but you
Okay. Should someone take over?
I think it's your screen sharing settings.
Upon all the promises you guys made in the morning.
Tell you, tell
Already
you.
5 minutes is gone.
Tala.
Tell you,
Tala.
Tell you too pressure. Why is that?
I tell you people, you are giving us doom to advice. What is this?
Is it okay now?
Yeah, d'accord.
All right. Okay.
Okay. Good afternoon once again. I'll be taking the lead with this presentation. We are going to talk about testing and debugging. This is group 5. Please, next slide. Kofi, next, please. Okay, so debugging is just the process of finding and then fixing bugs or errors in the code or source code. So you can do this right on the code. That's when you are writing the code, or after you are done with the software and you encounter any problem, you can just debug and then fix errors. And next slide, please. Okay, so how to, we have Python has an inbuilt debugger. So you just run the command Python -m and then pdb and the file name then to enter the debugger mode. Next slide, please. Okay, so there are 2 types of debugging. We have the static and then the dynamic. Next slide. So we are going to look at the static analysis. this refers to the computer program debugging. This is done right in the source code. So whilst you are coding, you can just do the debugging without having to run the program entirely. Please, there are a couple of advantages and disadvantages to using the static analysis. So the advantages are you can just locate the exact location or line where the problem or issue is, and then it's relatively faster to debug this way. The earlier reduction is also very resourceful in terms of cost. If you detect the error early, high chance of you not losing any more money in future. Let's look at a bit of disadvantages to this method. So this is a bit of manual, so you have to do this. It's a very time-consuming and tedious ECG. Wow. Sorry. It's a very time-consuming process. You need to do it manually. And then some of the automation tools can provide false negative and false positives. Automation is also very security threatening. If you automate most of the tasks, you can end up exposing your security. I think my colleagues will continue from here with a demonstration. Thank you.
Okay, so I'll take it from here. So we are coming to do a little demo on static analysis. Just like my colleague said, with static analysis, we do the debugging right in the source code. So as you keep on coding, you keep on writing your code, the IDE are automatically developed in a way that it's able to catch some errors, like let's say syntactic errors and sometimes even semantic errors. So we want to demonstrate with this code here, and let us see how static analysis is done. So I'll open my IDE a second.
Senior man Kofi.
All right, so I'm coming to now demonstrate it here. So let's say you define a function AWS class. You define a function like AWS class. I hope you can see the some little line being underlined here.
Of
So
course.
here, yes, so this one is a static analysis. It's telling me that there's something wrong. So after, you see, for a function has to have a body. So after giving the body to a function, like let's say results is equal to A times B. After getting this, on the first line, we earlier saw a line under the colon, but then this time it's here. Yeah, so that means that we are still in the debugging mode. We are still in the debugging mode. We are in a static analysis. We are able to find what is wrong and what is not right. So you can run the code. You can run the code to find a problem with. So let's say Python demo 3. So yeah, so with static analysis, just like our colleague said, the errors are straightforward, identified whilst you are writing the code. So the reason why the A and B are underlined is because we have not defined them. We don't know what the A and B are. So we can, let's say, A is equal to 3 or 2, and B is equal to, let's say, 4. So now, because our IDE has been developed to identify errors, I was able to know that, oh, A and B is supposed to have values before I can run the program successfully. So when I call the function, oh, no. Sorry, I have to print it. Yeah, because our IDE was able to help me to identify the errors, the function is now running. I don't know if what I explained here is clear.
Very clear, very clear.
Terry, please don't answer for us, we beg.
Yeah, is there a
Thank you.
question? Do you have a question that is there something that I have to explain?
We are good, we are good.
Okay, all right, sure. Okay, so then I'll switch it to our PowerPoint. Can we see my screen?
Yes,
Yes, we
please.
Okay, all right. So who's next? Is it Terry? Are you next? Dynamic analysis.
Terry for echo.
Terry, over to you.
Hey, manager, where is he?
All right, so let me
Kofi, can you please stop
okay.
sharing so that I'll share my screen?
All right, okay, sure.
D'accord. All right, can you please all see my screen?
Yes, we can.
D'accord.
All right, thank you. So I want to talk on dynamic analysis. So let me put this scenario. So when you, like in a football match, when before the players will come to play the game, the coach will have to give the formation to the team in the dressing room. Now sometimes surprises happen. Imagine the team is playing 4-4-2, and all of a sudden the opposition change passes to 4-3-2-1. Now the coach cannot take the team back into the dressing room to give them a new formation. You have to now change the formation on the field. That is how dynamic analysis is. It's a method used to evaluate and understand the behavior of a software system or application while it is running. So unlike static analysis, which sees code without executing it, and dynamic analysis involves observing the system in operation to gather data about its runtime and behavior. Now, so sometimes the behavior, the performance, and interactions with other components. So that is what dynamic analysis seeks to take care of. Now, I want us to look at some key aspects of dynamic analysis. Now, the first aspect is the execution monitoring, in which the dynamic analysis tools monitor the execution of the program to collect data on various runtime metrics, such as memory usage, CPU usage, and execution time. This also helps in identify performance bottlenecks and then insufficient code. The next one is the profiling, in which so profilers are basically they are tools used to they are used to measure the performance of different parts of a program. So they can also help identify which functions or methods are consuming the most resources and where optimizations are needed. The next one is tracing, which involves recording a sequence of executed instructions or function calls. This helps in understanding the flow of program and can be crucial for debugging complex issues. The next one is the memory analysis, where dynamic analysis tools can also monitor memory usage to detect leaks, buffer overflow, and then other memory-related issues. So this is particularly important in languages like C and then C++, where manual memory management is required. The runtime verification is also checking the program against certain specifications or properties during its execution. For example, it can be used to ensure that certain variants hold true throughout the runtime of the program. The last one is the security testing, which can be used to identify vulnerabilities that only become apparent during execution, such as in the SQL injection, cross-site scripting, and other runtime attacks. We also have automated testing, which I didn't add. Now, the next one is the tools for dynamic analysis. The first one is the Valgrind. The Valgrind is a programming tool for memory debugging, memory leak detection, and profiling. The gproof is also is a performance analysis tool for Unix applications. The Dynatrace is an application performance management software for monitoring and optimizing applications. And of course, we have the JProfiler and then the Wireshark. The Wireshark is a network protocol analyzer used for network troubleshooting, analysis, and software development. Let me take you through the advantages. Now, dynamic analysis also helps to detect problems accurately. Now, what does that mean? So it can detect issues that only manifest during execution, such as race conditions, deadlocks, and other concurrency issues. It also enhances test coverage. By observing the program's behavior in real time, dynamic analysis can help ensure a wider range of scenarios and inputs are tested, leading to more robust softwares. User experience insights. By stimulating real user interactions, dynamic analysis help in identifying and improving user experience issues. Let's look at some disadvantages. The first one is the performance overhead. The act of monitoring and analyzing a running program can slow down its performance, which might not accurately reflect the software's performance in a production environment. The next one is the complexity in setup and analysis. Now, setting up the environment for dynamic analysis and interpreting the collected data can be complex and requires significant expertise. So if you're not that good, you cannot be able to do that when it's in runtime. Now, incomplete part coverage. It also says that it may not be feasible to test all possible execution paths, especially in high complex systems, which can lead to missed bugs and then issues. When we are using systems that have that are highly complex, and then there are so many people or so many things happening on it, it may not be that possible to be able to see all the bugs and then be able to correct them. Sometimes man miss some, which will cause another issue to happen, and then basically can shut down or then cause complex issues. So that is mine. Thank you very much. I'm done. Oh. Hello?
Yeah, we can hear you.
Yeah,
done.
thank you, Terry. Calvin will
Kofi.
continue.
Kofi will do the
Kofi,
demonstration, then I continue with
please do the
assertions.
demo.
Yeah.
No, continue with the assertions and the login because my second demo is going to cover those ones.
Oh, okay.
Awesome.
And let me share my screen then.
Please do, please do.
Okay.
Hey.
Please, can you all hear me?
Yeah.
Yes.
Sure. Okay, so with assertions are a way to let the program test if a condition in your code returns true. Then if not, the program will raise an assertion error. So a minute. So here it says assertions are conditions such as the if statement that checks the value in the application. So like I said, if it's true, then it won't raise an assertion error. But if it's not true, then it raises an assertion error. So I have a little demo here. I think I can use this to explain what's going on here to you guys. So we have the dev log user age, and we have the asset statement age, which is less than or equal to 0. It should give you the message that invalid age was supplied. So there's nothing like this statement is wrong. It should be greater than 0, not less than or equal to 0, because there's no number less than 0. So the statement has to be asset age greater than 0, print invalid age. Sorry, return the message invalid age was supplied. The reason is that an age of 0 or less is typically considered invalid, whereas an age greater than 0 is valid. So for the assertion to check if the age is greater than 0, then it will raise an assertion error if not. So if you call the function with an invalid number, such as, let's say, with where the def log user age is, you put 0 there, it will raise an assertion error. If you also put -1 there, it will raise an assertion error because it's not greater than 0. I hope you all understand, please.
Yes, sir.
All right. So with log monitoring, log monitoring is the process of collecting or processing and analyzing data from various sources to identify trends, patterns, and anomalies. It also helps troubleshoot issues, improve security, and optimize performance. Simply means log monitoring keeps track of everything going on your system, and also keeps record of the last time a program was run or a last time a change was made. And there are some tools for log monitoring, which are the Splunk. Splunk is a comprehensive log monitoring and analytics platform. And we also have the Elk Stack. That's the Elasticsearch, Longstash, and Kibana. With this tool, it's an open source log monitoring and analytics stack. And we also have the Logly. But that one is a cloud-based log monitoring platform. Thank you. Derek will take the rest.
Okay, thank you, Calvin.
All right, Derek,
Come
before,
please, I don't have lights.
yeah, Derek. Yeah, Derek.
Derek,
Yeah.
Yeah, before you move on to software testing, there is a demo that we have to show here. Yeah, so let me take it from there. I believe you all can see my screen.
Yes.
yes.
All right, sure.
Yes,
Okay.
sir.
Yeah. So we want to demonstrate the dynamic analysis with the code here. So I want to create a new file here. So let me say demo4.py. Yeah, so basically for the dynamic analysis, just like my colleagues had already explained, those analysis are done, or those debugging are done during the runtime of the program. Yeah, so ways to do dynamic debugging is through logging, and also we have the Python debugger that can help us to do dynamic debugging. So I'll first tackle the assertion. We give an
Hello.
example of the assertion. So let's say the function log user age, parameter age. Yeah. And then
Kofi,
assert
please, can you go
that's
back a bit? We
um
missed you a while.
sorry. Sorry.
I don't know if it's my network, but we missed you a while.
Can you hear me now?
Yes, please.
All right, sure. All right. Okay. So I believe you can see my screen. All right. So with the assertion, we define that the age should be greater than 0. Yeah. So the age should be greater than 0. So this is our assertion. Now, for us to know that it's working, our assertion is working, we have to catch this assertion as an exception. So we will define a try block here where we have our log user age with, let's provide an age like -1. So assertion error as E, then we print the E. Okay, so we have this one here. So we can now run and see our assertion in operation. So I think it's demo 4. I was trying to demonstrate. So I was demonstrating the assertion, how to use the assertion. So here we've defined that we should assert that the age that we receive here in this parameter should be less than or it should be hold on. It should be greater than 0. It should be greater than or equal to 0 or it should be greater than 0. Yeah, so we have defined our asset age that it should be greater than 0.
I think that's your Zoom, what's it called? It's covering parts of your screen, so we can't see the top right of your screen.
The top.
Yeah, I think that's your Zoom, the Zoom window or something, like a rectangle. So you can move it down a bit, like to the middle, or you can move it to the right.
Is it okay now?
Now it's covering your terminal.
Oh shit. Okay, then let me find out so that I can.
You can move it in between both. So in the middle of, so the terminal is down, your code is up, and then this thing is in the middle.
I don't know whether it's okay.
No, I think you can just go back to what you were doing before. I think that was better than this. Okay, I know what you should do. Drag your terminal up a bit. Okay, it's okay, it's gone now.
Okay. Yeah, so sorry for so this is how we demonstrate the assertion. So after asserting that the age should be greater than 0, when you provide a negative number as a parameter or as an argument for the function, it's going to create it's going to catch this assertion error and print that the age should be greater than 0. So this is how the assertion error is being caught. And we also talked about login. So with the login, you have to import login. Then we use it to log errors and values that a user enter in a particular code. So after importing the login, you can now access the login by so we have login is equal to sorry. So we define the login with the file name of the log file. So let's say debug 5.log and the level of login. So let's say debug, yeah. Then after defining the login, you can now define a function and then use the login to catch any errors that occurs in the code. So let's define any function. So let's say AWS class. And a user enter a number. Mhm. Right. So we've defined a login with within our code here. So we can capture any value that a user enter. So so let's say we've given 5 to our function here. So I want to run it. Sorry. Yeah, Akosia,
Coffee.
yeah, I'm having a problem here. So
Module object is not callable.
check.
He's using a num parameter. Where did he define that? Yeah, the def AWS num. Where are you getting that to pass it in the function?
Yeah, so I passed the 5.
So we define the
Okay, the 5. Okay.
um,
Okay, so yeah, the error was on this line, the line 6. Yeah. So I've been able to log the value that was stored in this num here. So you can open your log file here. That's the debug5.log file. And then you'll be able to know the value that the user entered with this one. Yeah. And the final thing to do a dynamic debugging is using the Python debugger, which is PDB. So demo for the PY. So I'm in the debugging mode. So when you're in the debugging mode, you can use several commands to walk through your code to find errors and also values which are entered in your code. So for instance, I am in the import login. So I can put a break and let's say line 5. So after putting the breakpoint there, I can enter into that function with command S, and then I'm in that function. So I'll be able to know whatever that a user has entered. So let's say when you want to print a value that has been entered through the debugging mode, you can use P and our here variable is num. Okay. I think it's because I didn't call the function. So let me put a breakpoint at 8. And then, okay, yeah. So after calling this function, I can now enter it. Yeah. So after entering the function, I can okay, yeah. So after entering the function, I can now I can now detect the value that our num variable was able to capture with the Python debugger mode. All right. Okay. So I'm done with the demonstration.
Okay. Thank you very much,
you.
my brother.
Kofi, you can stop sharing for that shit.
So, Kofi, how did
Okay.
you
So
what key did you use to exit the debugger mode?
The debugger mode, I use the Python -mpdb, the Python debugger, and then I added the file name.
Yeah, when you're done and you want to exit.
When you want to exit, you use Q.
Okay. Okay, Musa.
okay, thank you, Kofi. So as the famous saying goes, never allow a bug to bite you twice. That's why my brother Kofi had to take a lot of time in giving us more understanding in debugging. So I'll be taking you through software testing. When we say software testing, it is the process of evaluating and verifying that a software application does what it's supposed to do or its intended purpose. So for example, you build an app to guide users to save. And then when you open this app, instead of giving the user some benefits of saving and recommending some banks and accounts to save with, it rather tells you to send all your money to your ex-girlfriend. So you realize that there's an error somewhere. So software testing is usually important so that you get to know that yes, the app is or the software is doing what you are supposed to do, what is intended to do. Okay, so let's look at some software testing. We have the acceptance test, system test, integration test, and then unit test. Can we go to the next slide, please? When we say a unit test, it's the smallest testable part of any software. It is the most basic level of testing, and a unit usually has one or few inputs with single output. So what this is basically saying is that it's a process where you test the smallest functional unit of a code. Okay, so let's go to the next one. Integration test. So integration test involves combining individual software models and then testing them as a group. So the purpose of integration test actually is to expose faults in the interaction between units. So let's say, for example, the fuel, let's go to car mechanisms. Let's say the fuel system, you can test the fuel system in collaboration with an exhaust system and then a working engine to ensure that there's no communication problems between these components. Thank you. Can we go to the next one, please? System testing. System testing is a significant stage in the software development lifecycle that involves testing the complete system to ensure that it meets the required, the specified requirements. So now the purpose of system testing is to evaluate how the various components of an application interact, and then the overall functionality, and then the performance of a complete and fully integrated app or software. Can we go to the last one, please? Acceptance testing. When we say acceptance testing, it's a formalized testing that considers the user needs, the business needs, and whether the software is acceptable for delivery to the final user. So in the context of engineering, here a functional trial can be performed on a product or a prototype before it is put on the market to ensure that the specifications are being met and it's it meets the needs that of the user you are sending the product to. Okay, so here ends our meeting, our presentation. If there are any questions, we are willing to accept them and answer them for you. Thank you very much.
All right, thank you, Group 5. Guys, any questions for Group 5? Okay, so since you guys have no questions, I would ask like 2 questions. Okay, Dennis.
Yeah, so thank you so much, Group 5, for the presentation. I mean, it was a great one. Just that Terry was acting like a politician, came to make us promises. I had one question during Terry's session. So he spoke about memory management at execution monitoring, and then the memory analysis. So I really did not get the difference. He says when the dynamic analysis, it's able to check the memory, something about the memory the program is using. And then he mentioned that same memory functionality, memory checking functionality under memory management and under memory analysis and under execution monitoring. So I want to know, is it different from those 2 stages, or is the same thing happening there? And then my second question was from the exceptions, but I think when you did the demo, I got it because from the insertion, the picture they use in the slide, I couldn't get the assertion. I couldn't get the difference between the assertion and the exception that we also treated. So I was a bit confused, but I think when he did the actual demo, it was pretty clear. So thank you.
Okay, so Terry, the first question.
All right, so Mr. Dennis, so what I said concerning dynamic memory analysis is that dynamic analysis tools can monitor memory usage to detect leaks, buffer overflow, and other memory-related issues. And I also said that it is important in languages like C++ and C++, where manual memory management is required. So that was what I said. I don't know if you really understand that, boss.
Okay. All right.
You're welcome, sir.
Okay, we can have group 6 now. Thank you, group 5.
Anytime,
And
sir,
I liked
anytime.
your what's it called? Your demonstrations. So you really made things more understandable for us. So thank you for that, and good job with the slides. People have
Anytime.
proved that you can work under pressure. So more pressure will be coming. Okay, group 6. Okay, beaches. Okay. So let's have group 6.
Yeah, hello, Akosia. Good afternoon to you and then to my honorable colleagues.
Afternoon.
Yeah,
Group
boss.
6. Group 6, are you in the house?
I do. Where is Fancy?
Okay.
Fancy.
So I will do my best. I will do my best to cover the entire presentation, but when I'm getting exhausted, I will get a lawyer. So be prepared, please.
Akosia, is he allowed?
All right.
Akosia, is he allowed?
Yes, it's allowed. So you have more
Now you
presentations to come. So what we do is, if you presented in this one, then the next one you get to just sit back and watch.
Hey, Kasayam from
that was master, Charlie. Is that take it?
D'accord. All right, good afternoon once again. DevOps and continuous integration, Python fundamentals. So what is DevOps? DevOps basically is a culture that came to bridge the gap between the traditional way of developing software application, whereby developers, QA, QCs, and operation guys are in, like they are in separate ways. They don't team up to work. So for instance, the developers will develop their application to some stage before, or even to its entirety, before the QA, QC guys will come in, and then they will run their tests and they will tell them, hey, everything is failing. So go back and then correct it. And then operations too, they will deploy and then they'll say, oh, it's not deploying on the production environment. So possibly the developers, they did everything on their development environment and everything was working fine. But here we find ourselves, once the thing gets to QA, QC, there are errors, or even production is failing to deploy. So with DevOps, it tries to bridge the gap between these stakeholders, developers, the testers, operation, and even other stakeholders. So that's the overview. Okay. So let's see what the slide says. The main objective or goal is to find out or get to know what DevOps is, then
Please,
identify.
Oh, sorry.
I don't see your slide.
Yeah.
Presentation.
Oh, sorry. Let me start sharing. Please, can you see?
D'accord.
Yes, we can see.
Okay, so let me start all over. DevOps and continuous integration, Python fundamentals. So we move on to the objectives. Defining DevOps, which I briefly explained. identify the goals of DevOps, identify the challenges DevOps came to solve, and then describe the culture of DevOps. So as we proceed, we will get to answer all these questions. Okay, so briefly, DevOps is a software engineering culture and practice that aims to unify software development, dev, and software ops, software operation, which is ops. The main characteristic of DevOps movement is to advocate for automation and monitoring at all steps of software construction. These steps range from integration, testing, and releasing to deployment and infrastructure management. So as I explained, DevOps came in to bridge the gap between developers, operations, and then QA, QC. And then with DevOps, you're able to release software application very fast, and at the same time, having the quality and the reliability as much as possible. So DevOps involves a culture, it's a culture way of, going about software development all the way from the beginning to the end, which is deployment. It also involves automation, where repetitive tasks like integrating whatever changes being done into the main code. So there is automation put in place so that we have this flow possible. It also follows the lean methodology and also measurements, monitoring, and then sharing. So let's have a look at this culture of DevOps flow. So dev will go through the cycle and then all the way to ops. Then at the ops stage, we'll be monitoring the application, monitoring the infrastructure, and then feedback will be given if there is the need for the developers to maybe come up with new features or patches or to make or secure the application or address any vulnerabilities. They do that and then the cycle continues. Okay, so we have several methodologies of the software development lifecycle. We have the waterfall, we have the iterative, we have the agile, and we have the, what again? I think, yeah, that's all I can remember. So the iterative, waterfall, and agile, and then DevOps. So the waterfall is like one stage has to be completed before you move on to the next stage. So for example, when you begin the life cycle, the analysis stage has to be completed before you go to the planning, the coding, and so on and so forth. So with the waterfall, every stage has to be completed before you move on to the next stage. Whereas the agile methodology, it involves the iterative. Iterative means as you go through the analysis stage, for example, you are gathering information, right? So whatever information that you gather, you can make use of it. So you can move to the next stage and plan with it, code, tests, and then deploy for your end users to see, what you have done so far, so that if there are any changes or any addition to be made, then it will be added. So with the agile methodology, you don't have to wait for one stage to be completed before you move on to the next, as compared to the waterfall. So as you can see from this picture, the waterfall, you move from analyze, plan, design, build, test, and then deploy. But with agile, it's divided into sprints. Sprint is like a time box sort of. So maybe 2 to 4 weeks, you need to complete this portion of it. Then like that. So it's divided into sprints. And then each sprint goes through more or less the entire process: analyze, plan, you build, you test, design, and then deploy. Then the next sprint like that. So you don't have to wait for the analysis stage to be completed, because sometimes maybe the stakeholders, the owners of the application who have contracted you to do, they themselves, they don't even know what they really want. They have fair idea, but not in its entirety. So if you want to gather all the information from them first before you proceed, sometimes it's very challenging. That's why this agile methodology really helps a lot. And it has a lot of similarities with DevOps culture. So we get to the similarities and differences between the agile and then DevOps. Goals of DevOps. DevOps is meant to bridge the gaps between traditional IT, software development, and quality assurance. DevOps is meant to be faster and more flexible. So, like I said, DevOps is very close to Agile. The only difference I'll point out here at this point is Agile focuses on the software development process, whereby DevOps focuses on the entire process, like from the software development to operations to deployment, like operations as well. So it's a complete flow compared to Agile. Agile focuses on the software development process itself, not operations per se. Okay. So DevOps is meant to be faster and more flexible. It also uses an iterative method where maybe the information gathered at the analysis stage can be used to plan, to code, test, deploy. Then any addition will be integrated into it. So mostly that's why we have what we call the continuous integration and then continuous deployment. So we don't wait for one whole stage to be completed before we go. So it's iterative. As we go through the process, if there's any change to be made, it will be integrated into it. So DevOps also bridges or reduces the need for specialized individual work. When you begin to develop, you might notice that it is easy to become immersed in your own work. So what this is trying to say is that you can get so engrossed in one thing instead of the whole thing. So DevOps also places focus on communication and collaboration instead of the traditional way where developers will focus like they focus on themselves, just developing their stuff. But with DevOps culture, it's not supposed to be like that. The DevOps have to factor in the QA QC, they have to factor in operation, and like that, operations as well. Also have to factor in there. So there's that continual communication and collaboration. So for example, I remember when we had a discussion, Petty asked that, okay, so does it mean you have to know one specific thing and then get to do, or you have to know the other thing? So with a DevOps culture, you, the DevOps engineer, you have to have an idea what the developers do, even to the level of knowing some of the coding, the languages they use, then operation as well. You have to know how the environment, the infrastructure, and all those things. Although in larger companies, there is this division of labor. So the DevOps engineer wouldn't have to do, all these. The job might be streamlined, maybe just the CI portion, the continuous integration, or maybe just a CI, CD, without necessarily bothering yourself with the infrastructure. Maybe someone will be in charge of the infrastructure management. Okay, so stakeholders, like I said earlier, DevOps is basically a culture, and it tries to bring on board all the stakeholders, collaborate, and then try to communicate on a level that there'll be a smooth flow of the application development process all the way to development. Then, okay, to continue, you have the collaborative culture, as I explained. You have the autocratic culture. This is often associated with entrepreneurship and innovation. So that's ad hoc. when something comes up, then you experiment. That's why we do have what we call the sandbox environment, where you can do all your experiments, birth new ideas, and eventually the ideas can move from that stage to developing stage and eventually to production stage. Then we have the market culture that pays attention to achieving goals, and then the hierarchical culture. Continuous integration and continuous delivery. So DevOps place a key emphasis on certain processes. So it focuses on continuous integration. What is continuous integration? Okay, let's say there is a team of developers, and then they are developing an application. So let's say one person will be developing a feature, another person will be developing another feature. And then they will be integrating these features into the main features, the main application at any point in time. That's why we have what we call the GitHub repo, the GitLab, the Bitbucket, and all those things. They are registry, source code registry, which help in that kind of collaboration, where we can all work on one source code. Just branch, do your own, and then later you can merge onto the main, yeah. So that's continuous integration. So DevOps normally also focuses on automation a lot. So as the developers are coming up or developing the features and integrating into the main, the DevOps has to also do what we call the CI, or the continuous integration pipeline. Let me take the CD out for now. So what will happen? What happens is that as they are developing it and attaching it, it will go through the pipeline to be tested. So if there are any errors, be it logical error or best practices error or bugs or whatever, then a report, we have various types of testing anyway. So a report will be generated, and then it goes back to them. And some of the ways are mostly, I think we use Slack. It's a very good platform that you can integrate into your CI pipeline, okay, or the automation that you have built. So if there is, at the end of the process, a notification will be given to the team, and everybody will see. Those who are authorized to see will see that, okay, this is what happened, and they can get to know even the report of the failure, and they can work on it. Then we have the continuous delivery. The continuous delivery takes part of continues from where CI ends. So once the CI is in place, the automation is in place, developers will work on their code, features, add it to be tested. If there is anything to be, they will be notified either on Slack, email, or whatever platform it's in place. Then the next stage will be the CD. The CD is where this application can go through the next phase, which is the delivery. It also go through other tests for other checks, security checks, vulnerabilities. Then you can even go ahead to, depending on how you want it. If you want the traditional way, you can just upload. The automation pipeline will be in place. That's a CD automation pipeline. And then you can upload to artifacts repositories like Nezos and other ones. Or if you are using containers, containerization, you can build your source code into what's a containerized form using Docker or whatever other application that you want to use, as a containerd and other ones, other containerization tools. And then after that, you can upload to the registry. The registry, we have AWS have their own ECR, Elastic Container Registry. We have the Docker Hub, which you can upload there. So once it's uploaded, you can have versions of it. The automation process will do the version for you. So you can have version 1, version 2, version 3. So everything is automated. That from the developers point of view, they are adding features to go through the pipeline, it will be versioned, and we will see. So at any point in time, you can even go back to the earlier version or however you want it. Then we have CD, which is continuous deployment. So the CD are in two branches, depending on maybe how large the company is and how they streamline their things. So you can have just CD straight in deploy, or you can have continuous delivery and then continuous deployment. So the deployment will eventually deploy to the production environment or to dev environment or staging environment. So with the production environment, that's where you and I, if it's, let's say, a WhatsApp application. So if you have really paid attention, you realize that every now and then you hook up to your WhatsApp and then there's a new feature that has been added. All these are achieved by this continuous integration, continuous delivery. So the automation pipelines have been put in place so that as they are adding the features, you will also see and then use it. So that's continuous integration and continuous delivery or deployment. Okay. So automation. Automation is very critical in DevOps because you cannot have this thing in place without automation. And there are several automation tools that we use, and Python is one of them. I'm sure that's why they've integrated DevOps into this Python course we are doing. And Python is a very powerful tool for automation. So with Python, you can integrate other tools to trigger your pipeline. So automation simply means that you get to, let's say you have repetitive, like this one, for instance, it's repetitive, right? So you want to put them together so that we avoid as much as possible human intervention to the barest minimal, okay? And like I said, Python can help you do that. There are other tools as well. You can even use bash scripting to write your scripts to do it for you. Or you can even, within, let's say, what's the name, GitHub, you can have GitHub, you use your GitHub actions to trigger. So the automation is having series of statements or code or instruction that have been put together such that when something happens, do this. So when the developer maybe are done with a feature and then they push to the repo, or maybe they do a pull request or a merge or whatever, do this. So based on the condition that happened earlier, then you tell your code to do A, B, or C. So basically that's what the automation does. And it's usually very good for repetitive tasks. And like I said, Python is very good for that. We have other scripting like bash script, we have a Groovy script we can use to implement your automation. So here, the slide is talking about over automation and then under automation and then bad automation. So there are instances where you over automate it. So if, for instance, the task changes a lot, then you cannot entirely automate it. You may have to maybe break it into portion and then automate the bit and pieces of it, not an entire task. So sometimes we tend to over automate and then the code will break. And then we also have under automation where that's the opposite. So if there are certain tasks that are repetitive that you miss out in adding or automating it, then you tend to have under automation. Then bad automation as well is when you completely break your code, because either you are trying to over automate it. Okay, so bad automation happens when you automate a process that does not work well. So the process is not working well, and then you try to automate it. You end up having a bad automation process. Then tools for DevOps automation. There are so many tools when it comes to DevOps. So these are the three main categories of the tools used in DevOps. We have the build automation tools, we have the test automation tools, and the deployment automation tool. Do we have examples here? Let me see. Okay, so I'll just mention some examples. So the build automation, what does it do? It automates the building process or the building of the application. And when you say building of the application, what does it mean? The application is oftentimes written in higher language, higher programming language, right? And it has to be either translated, interpreted, compiled, and built into a form that is more efficient to be used. For example, we add comments, we add some other stuff that will make it readable for you, the human coding it. But the computer doesn't need to have all these things. Just wants the instruction to carry on or to do whatever task that you are instructing the computer to do. So when you build, you remove all these things from it to make it more efficient, straight to the point, and even so that it doesn't even take a lot of space. So maybe your source code itself can be, let's say 20 megabytes, but when you build, you end up getting maybe 5 megabytes because some other stuff will be removed, and then you only focus on more efficient code for that. So that's the building, and we have tools for doing that. One is we have Maven or Gradle. They are used for Java-based applications. So most of these tools are sometimes programming language based. So depending on the programming language you use or you are using to build your application, you may have to go for some specific tools. And there are some which are also, let's say, generic or general, you can use for multiple programming languages. So if your program is, let's say, JavaScript, you can use Node or NPM, Node Package Manager, to build it. So the NPM is within the Node. So once you have Node installed, you have the NPM package, NPM to do the building for you. Then we have the test automation tools. The test automation tools, as you can see, automate the testing process for you. And the testing, we have various types of tests. We have the unit testing, we have the logical test, we have the code quality testing, and some of the tools are the JUnit, we have SonarQube. I think JUnit is for unit testing, SonarQube is for code quality testing. So we can have all these, some of these tools. There are so many of them. I can't mention all of them from memory. So these are the few ones I can remember. And we use these tools to automate the testing process as well. And although you see them separate, build tool, test tool, but we can have a more integrated form. Like, for example, Maven, they call it Maven build automation tool. It even has test capability integrated. So you can use Maven to build and test at the same time. Then, the next one is deployment automation. So deployment automation tools, we have so many of them. And all these three, build, test, and deployment, we can have other tools that can help you do this by integrating other tools if they need be. For example, Jenkins. Jenkins can help you build, test, and deploy because it has the capability to integrate other tools. So you can integrate Maven, you can integrate SonarQube, you can integrate which other ones for deployment. What's the name? What I remember, I'll add it to it. So you can integrate all these tools in, let's say, Jenkins, and Jenkins will be able to do it for you. We have other ones like GitLab CI/CD. GitLab CI/CD, you can also integrate all these to build, test, and then deploy your application for you. So CI/CD pipeline, what is it? the automation that you build to carry out the CI, which is the continuous integration, and then the continuous deployment, is what we call the pipeline. It's a series of stages. So you have maybe stage 1, do A, do this, stage 2, do that, stage 3, do that. So what I've realized is that most CI/CD engineers or most pipelines that I see, they are normally categorized into 2, like the build stage and the deploy stage. And within the build stage, you can have so many stages. Test, maybe git clone your repo, test, Dockerize, and then push to Docker, can be in the build phase. Then you have the deploy phase, where you pull it's always, I mean, a best practice to push your code, be it in the form of artifacts to artifact repository, or sorry, registry, or to send it to, if it contains either AWS ECR or Docker Hub registry. So that anytime you need it, it helps in versioning as well. And anytime you need it, you can get it. So the build phase will pull from this registry, test it again for security vulnerabilities and other tests you want to perform on it before you finally deploy to the environments you want, be it staging, development, or production, where, if it's production, where the public can access. So the CI, continuous integration, I've explained earlier, it takes care of the little integration of the features and code that developers will do into the main code. So any feature that is done, there is an automation pipeline or a CI pipeline, which will take care of that, do the test, and then if there is any error, you get notification either via Slack or anything. At the end, I will do a demonstration. I hope, okay, let me speed up so I can do the demonstration. Then I was trying to integrate Slack on Jomax Slack platform, but it looks like I wasn't allowed, and I didn't have much time to switch to other platforms. So, okay, then the continuous delivery, which I've explained. I mean, so the continuous delivery will be the pipeline, the CD pipeline in place, which has been automated either using Python, within Jenkins using Groovy scripts, or within GitHub using GitHub Actions, or within GitLab using GitLab CI/CD to do the continuous delivery. So basically, you have stages which will pull your application image. When you containerize it, you get something called a template, and it's an image in the form of image. So that template, when you pull, you can create instances of it. So I can create instance A called container A, instance B called container B, like that. So you pull it from the registry and then you deploy it. So with a CI/CD in place, we have a complete cycle. You plan, you code, you build, test, release, deploy, operate, monitor in iterative manner, not a waterfall manner, where you have to wait for one phase, to be completed. So I've already explained this. Looks like we are done. Okay, so I'll jump on to the demonstration and demonstrate how we can build a CI/CD pipeline. Okay, before, let me share. I'm sharing screen already, so let me just give you a teaser what we are coming to do. Okay, so please, can you see my screen?
Yes.
Yes.
Did you hear the sound as well?
No.
No.
Maybe because I'm not sharing the sound, but
I can
once we are
see
done,
the mute button on the screen.
Okay. Can you hear now?
No.
Yeah, I have to stop sharing and share my audio before I think you can hear, but we'll get to that. So this is Netflix application. This is what we are coming to deploy. So we'll pick, this is in my GitHub account or GitHub repo. I have a GitHub repo. So we're going to pull it. I ignore the build phase because it takes long. When you are building into the container image, it takes long. So I eliminated that one. So I ignore that one, but we are going to pull it from the container registry and then deploy it. Okay. So we are going to use Jenkins. So I tested it, as you can see. This is a typical pipeline. You start and then you end. So once you start, the first stage is what? Tool install. So you install the necessary tools that you use to build your application and so on and so forth. Then the next stage, I've clean my workspace. So if there are older stuff, clean everything, make it ready for the new one. Then the checkout from GitHub. So it's going to pull the repo from GitHub. Then install dependencies. This Netflix was built with JavaScript, Node. So we have to install the dependencies using npm, and then finally we deploy to the server, and then you can access it from here. So this, what I did, I created EC2 instance and did all this. Okay. So let me go back to show you the instance I created. So this is my okay. So this is an instance DevOps demo, and you have to set your environment. What's the name? Your security group very well to allow your application. So what I did was that, let me log in, SSH into it just briefly. I won't spend so much time. Where is it? This one. Okay. No, not this one. Sorry, just a minute, guys. Should be this one. Okay, so it's this one. So let's SSH into it. No, not this one. Where is that? Okay, no problem. Let me just open another one, another shell. I was already having a shell. I can't locate it. So CD. Okay, I'm trying to locate my key pair. Okay, so now SSH. That's get it. IP address. Okay. Okay, so in building your pipeline, you need so many tools. So you have to identify the tools that you will need. So I'll briefly explain what I did. So ls, okay. So what I did was first to create a bash script called docker.sh. And this will help me install what we call Docker. And Docker will help me build container images. So the Jenkins you saw, the Netflix you saw, they are all containers. They are not on separate servers. So everything is on one server, but they are all in containers. So I use this Docker to do it. There's one tool that you cannot run away from. Then this one is Docker Compose. This is a file that I use to create my Jenkins. That's the CI/CD tool or the platform that I'll be using. So I'll just do, okay, let me do cut of this. I won't go through just to have a look. Because in the, okay. So as Akusuya taught us, you see, shebang, you can never run away from it. So this is just the commands you run, you put everything together. And I didn't even add error handling because it's just for demonstration purpose. Okay. So you install, you do update, upgrade, install your Docker, you give the necessary permissions and stuff like that. So you give the permission here, chmod 66 and stuff like that. Okay. So this for the Docker. I would need the Docker to build my images or containers. That's why I installed it. So now let's see the other one. Cat Docker compose. Okay. So this is called what's the name? This is a YAML file. YAML. It's just like similar to HTML. What's the name? Akosia, please remind me. It's what
HTML.
HTML, right? XML, sorry, XML. XML, I mean, yeah. It's close to XML. So you specify your services, then the individual service. So the service, I have only one service, which is the Jenkins. Then 8 parameters. You specify the image. So this image I'm pulling from the public registries by Jenkins company. Yeah, they have is public. This official public images. So I pulled it and then run it. Okay. So you put the image and then you use it to generate instance of it, which is the container. I gave it a name, the ports, numbers, and everything. So let me not go into the details. The network, the volume, everything. So basically, I want you to have a look at the flow, the tools that we use. I've talked about Docker. I've talked about Jenkins. So once I have it running now, you do what we call Docker images. So these are the images I have pulled. Okay, when you do Docker image, you want to see the images you have put to your local machine or your local system. So I've put the Jenkins, as you can see. The tag is the same as a version. Then, so this is the Netflix that I pulled from the registry as well that we are going to deploy. So ideally, I should have picked the source code that, like once I pick the source code directly from GitHub, I have to build it, get my container, push it, then I can now pull it again to deploy. That's how the process is. Okay. So these are my images and these are the containers running. Let me briefly show you. Okay, so I have 2 containers running. As you can see, we have the Jenkins, which is this one, and I have the Netflix. So just to let you know that they are all containers. Okay, so now let's go back to Jenkins. Unfortunately, I've already logged in. So let me log out. So once you do the installation, it will give you a default password. You enter and then you change it to your own. So I've done that already. So I'll enter my login details and then sign in. Once you sign in, we have what we call manage Jenkins. Okay. So use this to manage your stuff, like the plugins. I told you that Jenkins has the capability of integrating build tool, build automation tool, testing automation tool, and a deployment automation tool. So once you use by the help of manage Jenkins, you can do a lot of things. You first have to get the plugins that you want to use. So you go there and grab available plugins. There are so many plugins. People have built this for you. Just get the one you need to do your work. For example, let's say Maven. You see Maven, where is it? Maven, so many even types, depending on what you want to do. We can, okay, I think some of them have already grabbed it, so I won't see it here. Slack, you can see Slack as well. So whatever you want to do, it's likely there'll be a plugin there already. So you get a plugin, you install it. So after, let's say I want this plugin, you select and then you click install to get it. So once you are done, you go out from here. Then we have the next stage is tools. Some of the plugins, you need to go to tools to install them or configure them. So in our case, I had to configure what we call Node.js. As you can see, edited. So I come here, I give it a name, Node 16. I select the version. So I'm selecting automatic install. So there are so many versions, you select it. But for the purpose of this application, I chose version 16. I think the latest should be 20 something, 22. Yeah. So once you are done with the configuration, just click on what's, I hope I've not altered anything. Okay, just click on save. Then you come to the global configuration. This is tool specific. Then you have the global configuration. Then you do your configuration as well. Normally, the first part is for the host, which is the Jenkins. You don't do much here, just accept it. And then you can, in fact, you can integrate a lot of things, metrics, monitoring, and so many things, but we want to keep it simple. Then you come all the way down. I think here I didn't even have much to do because of the simple nature of what we are running. The only thing I tried to do here was the Slack, which unfortunately didn't work. So I came here to configure my Slack. You have to give the workspace name, which I did. You have to create a token. There's a process you go through. Slack, they call it Slack application, whatever. You go there to generate your token. And then you come and install your token here and then add it. Then you select the channel you want to put your notification onto. If you guys have seen, I created a channel, DevOps demo. Oh, okay, I made a mistake here. Uh-oh, the wrong spelling. That's why it didn't work. Demo, okay. So once you get this done, then you test your connection. Oh, sources. Okay. So typo error. Okay. So with this, I mean, you can't run away from typo. You have to embrace it and be ready to face them. So we are successful. So when you go to, let me open the Slack, you see, where is it? This one. Okay, can you see that? Slack Jenkins plugin, you are all set on this address. So you can get notification. I think this is public, so you can all see. Please, you can check. Okay. Then, so after everything, you save as well. Okay. So now that we are done, there's one more thing we call the one more thing, which is the credentials. So whatever credentials you want to use, in this case, Slack, I had to, once I go to Slack to generate my token, it's just like it's similar to a series of like about 19 characters or more, a lot of characters. So you count the credentials and then you create so this just like we have in AWS Secret Manager Service. So to help you store all your credentials. So I've created two so far. One is the server, to be able to deploy my application to the server. I will need permission. So this is my credentials to do that. I use the key pair. So this is the private key pair. And then we have this for the Slack. Okay. How do we do it? Just briefly. You come add credentials. There's so many credentials types. You have username with password type or kind. We have SSH, this is what I use, the private key. We have the secret file, we have the secret test, we have the certificate. So anyone you select, you put the details there, and then make sure you remember this name, the ID that you give, because you're going to reference it in your automation script. Then you click create, but we are not doing anything, so you just go out. Okay. So now that we are done with, so if it's Slack we want, whatever tool we want, you go to plugin to get it. If it has two specific configuration you need to do, you come here to configure, then you come to global to do the global configuration. So once we are all set, now we build the automation. We call it, we go here, let me see, dashboard. I can get it from here. So this, what I did, okay, but I will do a new one. We go to new item, then you give it a name. You are coming to build a pipeline, automation pipeline. So you give it a name, let's say demo 2. Then you select, you have types. I don't want to bore you. So let's select just pipeline. Then, okay. Okay, so you give it a description, demo 2. Okay. We are keeping it simple. So you're not going to do anything here in the general. This configuration is categorized in general, advanced, and pipeline. The only thing we did here is just give it description. So it goes straight to the pipeline. Okay. So the pipeline, we paste our automation script here. And in this case, I'm using Groovy scripts. Groovy script is what Jenkins uses. So if I want to use Python, then I'll just like Dennis demonstrated and the rest of the guys demonstrated. You create your Python scripts. So let's say demo2.py, and then you put your scripts, and I'll show you similar scripts. This is a similar script. Let me see this one. This is a similar script, this one. So import Jenkins, import request, then the server, the Jenkins server, you give it an address. You put in your username, your password, but there are better way of handling these credentials so that it doesn't get exposed to the man in the middle attack and all those bad boys. Then you give it a name. So what we are going to do there, you can use Python to do the same. So it all depends on you. So see, this one is going to send Slack notification that, hey, it's successful. So it is a very simplified Python script that you can use to achieve the same thing I'm coming to demonstrate. I've not tested this one, so I'm not going to use it. So back to our Ruby script. My script is here. I think it's here. Okay, so this is my script that I was running. Let me add, okay, so let me copy and then paste it here. Paste. So we run this demo, and then if there is time, I will, now that I know my Slack is working, I'll add the last stage of the Slack, and then we test that one as well. So if you want to appreciate the code, I can briefly, I hope I don't bore you so much. So this is how the pipeline scripts using Groovy, this Groovy script, not Python. I've showed you Python. So this is using Groovy script. So this is the name. Normally the proper name is Jenkins file, but because I already have Jenkins file, that's why I call this one Jenkins file 5. So it's not always starts with pipeline, and then you have your curly braces. Then within it, you specify agent. Agent is the one going to the master. We are going to use any. So in this case, the agent will be our master. If you're running master and slave, then you can have other stuff. So we keep it any. The tools, I'm going to use Node to build my stuff, although just to demonstrate. So what we have, I don't need this, but if I'm to do the Docker building, then I'll need this. Then the environment. Environment is where you specify your variables, your secrets, and all those things to be used. Then, so these are the top portion. Then we go to the stages themselves. I told you the pipeline is, if you are using Groovy script, not even Groovy script, all the ones that I've seen, whether GitHub Actions, GitLab CI/CD, they all segregate into stages. So we have stages, okay? So stage 1, we call it clean workspace. So if I put my cursor, so this stage 1, then I have another stage, which you see in the pipeline that I earlier showed you. So check out from GitHub. It's similar to the Git clone that we've done. Have you done Git clone? Okay, maybe you have not done Git clone. So it is going to do the Git clone and the branches main. Then dependencies. So it's going to install your dependency. If you are familiar with Node, always you have your stuff in what we call the Node, is it Node modules or something? So all your dependencies will be in one file. So they are just, okay, we have package.json, which will have the references. So once you do the installation, then you go into the module, the node underscore module or something. So you have to install your dependencies. Dependencies are what the application will depend on in order to function correctly. So install your dependencies, and then the other stage will be, like I said, I omitted the building and pushing to a Docker, I said Docker container registry, because it takes time sometimes. Many times it takes time. So straight, we move to the final stage, which is the deploy to server stage. So as you can see, they are in stages. So these are scripts doing the deploying to the server. Okay. So now that we are done, let's go back to here. Okay, so the code that I briefly took you through is what I've pasted here. And I'm using a port number. You can keep it the default, which is 80, or you can give it a port number. Sometimes it's used, so you have to specify another one that you are likely, it is likely that it's not in use. Okay, so once you are done, you just save it, and then you build. So once you build, you go to stages to see your pipeline. Oh, it's too fast too. Okay, because it's nothing much. So the tool install, which is the Node.js, is done. The clean workspace is done. The checkout is Git cloning from GitHub is also done. And then now we are at install dependencies. It's going to take a little while. Then finally, it will deploy onto the server, which I earlier showed you. And then from there, because I specified, so you pick the server IP address, which you can get when you go to your AWS console or whatever your server is. You grab the IP address, the colon, the port that you are exposing to use. So our pipeline is done. So this is the DevOps automation or CI/CD that the presentation talked about. As you can see, you have your build, you have built, we have, okay, this one doesn't include testing. I just wanted to keep it simple. So I didn't include testing. So we could have included testing in the stage, okay? So I had to do the testing for you and then deploy onto the server. And voila, we can see our Netflix deployed. So this is a web application. You can have a mobile application, and it follows similar methodology or similar culture where you have your CI/CD pipelines in place, and then it will go through, it will be testing, and whatever you need to do at every stage will be done. And there is that continuous integration. So we can even go ahead to, I remember the other group talked about monitoring and logging. So there are other tools that we can use for monitoring and logging. We can even integrate, I think AWS CloudWatch can help you. We have Prometheus to get the metrics similar to CloudWatch. We have Grafana. Grafana will give you that visual look, like a pie chart and all those graphical look of your the performance and availability of whatever you're monitoring. And what we monitor applications for performance, usage, so we know whether to scale up, down, or whatever. We monitor our infrastructure, the service they are running on. We need to monitor as well. And if there is the need to even provision more EC2 instances, we can do as well. So what again? Let me go back to the slide. I think I'm good. I'm done. So if there are any questions, then my team and I will take it up. Thank you very much. But before, let me help you have a feel of the audio. So I'll stop sharing and then share my audio.
Senior,
but you can equally access it. You can access it from your browser. So let me paste it. You can equally access it from your end. So control, where's the chat? Okay. Paste. So once you click on the link, you also enjoy it. Thank you very much.
All right.
Any questions?
Thank you, Ima.
Thank you, brother Ima. Thank you very much.
For that really insightful presentation. I'm sure some of us can even put like 3 months DevOps experience on our LinkedIn today, because that was really so insightful. So when
This is
we
20 years, so 20 years experience.
So when we talk about DevOps, we are just mentioning we're talking about the practices that gets a middle ground for quality assurance, for software development. So we looked at the software development lifecycle earlier, and we saw that inside of these stages, there are various roles and there are various activities or operations that go on. So DevOps is just bridging the gap between these various departments when it comes to deploying code. So when it comes to you creating your web app or you deploying any application, and even after the application has been deployed, the maintenance, all those things that you have to do to maintain or to still manage the application. Sometimes if there are updates or there are new versions of the application, yes, you would have to go through all these processes again to be able to push whatever changes or whatever new features to the users of your application. So that is what Group 6 helped us understand today, the practice and culture of DevOps. And we looked at continuous integration and continuous development. There are a lot of DevOps tools that you can use. There's GitHub Actions, Terraform, Docker, Kubernetes, and the one Ima took us through today, which is Jenkins. So a combination of them, or even sometimes just a single one like GitHub Actions, would be able to get you whatever results that you desire inside of your DevOps operations. So that was the earlier part of the presentation. And for the latter part, Ima, being a one and only DevOps engineer, just gave us an insight into his day-to-day as a DevOps engineer. So those of you crying in the chats, he was just giving us his day-to-day, let me say, but then the bigger picture of it, or the whole point of it, is we understanding DevOps and what DevOps seeks to do. So please, I hope we handled or we the understanding is clear with us. Guys, I hope that understanding is clear of the essence of DevOps.
Yes.
Okay. And
Some
as
of
I
us are
mentioned,
trying because we want to get there, but this one.
oh, it's step by step. So Ima didn't get all of this in a day. So it's step by step, tool after tool, process after process. So just learning them. As I mentioned, this is a really foundational class. And what we do is we expose you, or we pick your interest enough so you would want to further if there's any domain or there's any field that sparks your interest. So those of us whose interests have been sparked today, we can reach out to Ima. I'm very sure he has a what's it called, a roadmap for us to follow too, so that we can also be as good as he is. So thank you, Ima, and thank you, Group 6. If there are there any questions before we bring the class to an end?
Yeah, so is it the website he deployed? I wanted to find out if it was the official Netflix or it is one that he developed himself for the demo.
Okay, Dennis, I didn't develop it. DevOps, you don't do the development of the application. So this one I forked from someone, and then I used it to achieve my DevOps goals.
Okay, so it's not the official like Netflix website.
Well, I did not really pay attention to where the guy got it from, whether
Okay.
it's official or not, but it's very close to the official.
Yes, because I was seeing even the videos, the content, but just that the link was so are we getting the link not
So, Dennis,
or
I think it's more of a duplicate of what Netflix is doing. So they're able to duplicate it,
okay.
right?
Okay.
So Ima, my next question was like, you see, when you access the website, it gives you the not secure response. And then we treated certificates. So does it mean that it doesn't have a certificate to secure
For
the
now, it doesn't have, but we can do it.
Oh.
There wasn't much time for me to do that. That is why.
Oh no, I just wanted to know. So that's okay.
Yes, it's done. It's doable. It's doable.
Okay.
So if you want more
Please.
insight, you can see me and I'll walk you through.
All right. Okay.
Yakubu.
I guess you are hosting the next class, I guess.
Yes, hello. So the issue of the certificate that Dennis just raised. So with this one, it has nothing to do with the port, right? Because if you are, let's say if you're accessing through port 80 is insecure, but port 443 is secure. So so whether you access through port 443 without a certificate is still not secured. I just want to ask.
I don't think you can access through 443 if you don't have the certificate.
Okay. Okay, all right. All right, thank you.
You're welcome. So Ima, he's asking.
Okay, yeah, please go ahead.
He's asking about the 80 and the 443. HTTP, you access with 80, with port 80, and 443 is HTTPS. So he's asking that
Yes.
if you do not have a certificate, but you want your users accessing through 443, would that be possible? Yakubu, was that your question?
Yes.
Okay.
Yeah, I think the answer you gave him is that's okay, because whether you use 80 or 440, once you don't have the certificate, it will show not secured. So with this one, it's even going to be pretty straightforward. I already have domain with AWS, I'll just add a load balancer and then point it to it and then give it a nice domain name. Sorry, no, my name. So maybe Netflix dot my domain name, and then you can access it securely.
Okay, thank you, Ima. Derek, also answer.
Okay, I appreciate Emmanuel, Tali, thanks so much for that insightful presentation. You said the site it wasn't original, like that's Netflix, right?
Yeah, it's a clone.
It's a clone. Oh, okay. But I want to know, is it advisable to do that if Netflix happen to see this or know this? Would it not be a problem, or is it advisable? Is it okay for other people to also do such a thing?
I think it's for demo purpose, so that should be fine. If I want to go ahead and make it on a production level for maybe my customers to use, then I'll face problem. I think Joshua wants to add more to it.
Yes, so I just wanted to add just this. So there's a particular software that I can use to clone any website in this world, right? So I would extract the source code and it comes from my device. Then I would just use VS Code to repackage it and then do some small changes around it.
Okay,
Joshua.
so in that case, are you
So that's going to be
cloning just
Share
the
the link, share the link, share the link.
are you cloning
So,
just the interface, or you're also cloning the functionality of it?
I'm cloning the functionality and then everything.
Oh, okay.
What about the database? Are you also cloning
What
that?
software is that? Please share the link.
Yeah,
Share the link, share the link.
So in this case, but in this case, I'll not be able. I have to create my own server side, right? Like in
Yeah.
case of
API
backend,
calls,
right?
yeah.
API calls and then those kind of stuff. But there are some pretty ones that you can keep it.
Okay.
Share the link, sir.
I mean, it'll be 10K.
So Dennis, I had an update on the lab that you guys were facing issues with. So please share your screen and let's do that quick. Derek, is there something else, or Ruben?
I just want to what our brother Derek asked. I think for educational purpose, as our brother Ima said, this is for demo and for educational purpose. I don't think there will be any issue. Thank you.
All right, yeah, so you're right.
Oh,
It's when
thank you so much.
he tries to market it or sell it or something, that is when they'll come for him. But for demonstration purposes, I think this is fine.
Yes, and even in this case, I think Ima, it was hosted in Git, right? The repository, right? That's where you fetch it from, right?
Yes, please. Yes.
Yes. So it's
I cloned it.
It's open, so there's no issue. It's an for education, like my brother said.
Oh yeah, it's open. Yeah, it's not a private web.
Yes. So the other one that you can keep it like for private at that site too. Yeah.
Yeah, so click on the
please,
first one, the lab.
Is it the programming labs?
Yes, the Hello World. I should have asked you this first. Before you, after you submit, do you end the lab?
No, you don't end it.
For me,
Yes,
I ended it.
Yes, I think that's where the issue is from.
submit
The
and
lab
end.
should still be running so that you're able to move on to the next one. So while the lab is still, so after submitting, don't end it. So while the lab is still running, then you click, there's a small next button down there somewhere.
No, I was here.
Yes, Derek.
When you submit it, that will be all. It will end it. Once you submit it, it will grade it.
But it doesn't end
It will grade it, but not end it.
It will still be running, but you won't be able to. When you do the next one, it won't be able to what's the name, grade it for you. It will end it there. So the thing is, you have to
Okay.
finish all before
So
you submit.
someone from the other cohorts, and this is what they did. So you scroll to the bottom, there's a next button there that you click on it.
So Akosia, does it mean after going next to the end, everything is just 1 point, or each one you get 1 point for it?
Each one has their point.
Then you have to submit for each one, right?
Dennis, you already submitted for Hello World, right?
Yeah, so I did hello world, numeric data types, and string data type.
So you've submitted, like you clicked on submit for Hello World. So when you scroll down, I saw the next.
Yes.
Yeah, so click on it. And you said you've already done the numeric one, right?
Yes, I've done this as well.
And then you couldn't submit it.
And then I did the third one. So when I did the third one, I was like, okay, I've done the first, because those were the topics we had treated so far.
Okay.
So I clicked on the submit so that as we move along, I'll come and do
The
the
rest.
But then when I submitted, I realized that it only scored me for submission, but the works I had done were still 000.
Okay, so but when you
Then now
click,
the submit button is no more there.
it's not even there.
Yes.
Scroll to the bottom and let me see. Okay. I click on Start Lab.
It was already running because the AWS was green. So it started now because of this green.
Okay. And the submit button is still not here.
So no, yeah.
Click next. So these are the ones that you've already completed.
Yes, I have not done this one. I've not, from 4 going, I haven't done them. I did 1, 2, 3.
Okay, but when you were doing them earlier, was the submit button there?
Yes, until I clicked on it.
Okay. Then I have to meet with him again and find out what exactly is going on.
Yeah.
Because when I told him, he told me there's a next button down there, and always make sure that the Start Lab is started. So I'd have to find out maybe more detailed, and then I get back to you guys.
Okay. I want to
Okay.
even see if I could still access the files I had already created for the work.
And Akusia, I also realized something. That particular lab, it is not time bound. I didn't see any time when you started the lab.
Okay.
I don't know if one saw the time, because the rest, once you start the lab, you see the time reading. I don't know if anyone saw it as well.
Yeah, there was no time. But then mostly I end the labs because of this costing. They said it will keep so because I see that my files are still there.
Okay.
But yeah, they will still be there.
So this is
Okay, so it's
the
just left to the submission, that's it.
yes.
Yeah.
So
Okay.
when I did these first 3, then I clicked on the submit. But then it didn't score me.
Okay, so we looked at the picture that you sent, then the submit button was there, but right now the submit button is not there. So the picture you put in the technical group, that's what I showed to him.
But now it's no more there.
Yeah.
Because you ended the lab, that's why.
He didn't
I
end
also
it.
think
Dennis, did you end it?
Previously?
No, right now.
Right now, no, I didn't end it.
Previously, I mean previously. Because once you end it, it will go off. That's what I realized about mine too.
Let me
Because
see.
that's after I did the first one and then I
Do you think I
submitted.
should reset and see? There's a reset button here.
Okay, reset, let's
So
see.
we won't do it again.
I don't mind doing the labs again. Okay.
Akusia,
Yes, David.
total the lab over 1. Okay. It is not over 7 or 8, over 1. I do,
Yes,
I
I
don't know,
told you.
if you attempt one lab, that's in the hello one, then it calls you automatically. So you get 1 over 1. So I
So
don't know if
even
you're
if
supposed
so even if you do the rest, your
to,
score
yeah,
doesn't change.
1, yeah.
Ah,
That is
okay.
yeah. It's over 1, it's not over 7.
It's still the same.
The submit button is not there.
Yeah.
Okay. Then if you have your 1 over
Okay.
1, then I think that's it. So as I said, let's not worry about the what's it called, the submission. Let's just do this for the experience.
All
Okay.
right.
Okay.
But
See
what
you
I was
guys
thinking was
tomorrow.
after you go through the whole thing, I think after the last one, then you're supposed to submit it.
And the submit button is not even there.
I think we have to go according to what you're saying with
And
experience.
the submit button is not even there.
Akosia, what I realized from my issue was when there's no submit button, it automatically submits. So like when you get to grades, when you click on grades, you see it's 1 over 1. So when there's no submit button in this case, if you should end the lab right now and go to grades, you see it's already graded.
Okay.
And now
No.
that's what is showing here now. So
No.
that means it's
So we
already
can see,
submitted.
we can see that he has 1 over 1.
Yeah,
So
that
that
is
was the
already.
first submission.
Yeah. So I think
Because
that's
I
okay.
clicked the first submission, yeah.
I think
So
it
I think
affects the rest.
But if you don't,
so automatically
let's say
once
you
you are
do the
done and you
lab,
click on next, it grades the previous